Good day, my name is THEA VILLAS and I will be explaining all about the law of thermodynamics. What is thermodynamics? Thermodynamics is a branch of physics that focuses on the relationship between heat, energy, and work, and how these affect matter. It explains how energy is transferred and transformed in different systems, from simple objects like a cup of coffee to complex machines like engines. So there is 4 laws of thermodynamics. First is zeroth law, second is first law, then second law, and lastly is third law. First is zeroth law of thermodynamics. The zeroth law states that if two systems are each in thermal equilibrium with a third system, then they are also in equilibrium with each other. This means that if two objects have the same temperature as a third object, they must also have the same temperature as each other. Example, a hot cup of Milo and a cold glass of milk, when left in the same room, will both eventually reach room temperature. Similarly, a bowl of soup and a bottle of water left on a table will both adjust to the same temperature over time. This law helps define temperature and forms the basis for the concept of thermometers. Now let's proceed to first law of thermodynamics. The first law, also known as the law of conservation of energy, states that energy cannot be created or destroyed. It can only change forms or be transferred. In other words, the total energy in an isolated system remains constant. The change in internal energy of a system is equal to the heat added minus the work done. This is the formula. Proceed to real-life example. In an electric heater, electrical energy is converted into heat energy. This heat warms up the air in a room, increasing the room's internal energy. This demonstrates that energy changes form but it is not lost. Now that we understand first law of thermodynamics, let's proceed to second law of thermodynamics. The second law states that the total entropy, disorder or randomness of a closed system always increases over time. It never goes down. Entropy measures how disorganized a system is. Over time, systems naturally move from order to disorder, and energy tends to spread out evenly. Example, when cooking fried rice, heat flows from the hot pan to the cold rice. The rice absorbs the heat and changes form, becoming cooked. This process cannot be reversed. The rice cannot become raw again. This shows the one-way direction of heat flows and the increase in entropy. Lastly, third law of thermodynamics. The third law states that as the temperature of a system approaches absolute zero or negative 273.15 degrees Celsius, the entropy of the system approaches a constant minimum value. At absolute zero, molecular motion nearly stops and atoms are perfectly ordered. Examples of this is ice cubes and freezing food. Let's start with ice cubes. As water freezes, its molecules arrange in neat crystal structure. At even lower temperatures, this structure becomes even more orderly. Then in freezing food, as the temperature decreases, the motion of molecules slows, and the food structure becomes more stable and ordered. Conclusion: the laws of thermodynamics describe how energy moves and changes in the universe. The zeroth law defines temperature and equilibrium. Meanwhile, the first law explains energy conservation. And then the second law describes the natural direction of heat flow and the increase of disorder. Lastly, the third law defines the behavior of matter at extremely low temperatures. Together, these laws are essential for understanding physics, chemistry, and many real-life processes, from cooking and heating to engines and refrigerator. That is all for today. Thank you for listening.